Hello, I'm Floyd Maxwell, justthinkit.com, coming to you with a video called Toxic: How Science Measures Harm. This video has been prompted by dealing with trolls, dealing with people online that when they want proof, they don't believe it, they don't trust whatever you present to them. This is intended to pretty thoroughly arrange toxic stuff using one standard, a scientific standard. So let's have a look here. Our lives are full of hazards. The press gleefully brings fear, uncertainty, and doubt into our homes on a nightly basis. So how do we figure out which risks we actually need to worry about? I've created a list of toxins, there's a final ranking, and some conclusions. But first, an introduction. In transportation, the biggest risk is our favorite toy, the car. Sadly, 33,561 people perished in car accidents in 2012. Yet, surprisingly, death by car doesn't even make the CDC's 2011 top 10 list. Number 1, heart disease, 597,000. Cancer, number 2, 574,000. Then a big drop down, number 3, chronic lower respiratory disease, 138,000. Number 4, stroke, 129,000. Number 5, accidents, 120,000. Maybe the car accidents are mixed into that accidents figure. Number 6, Alzheimer's disease, 83,000. Number 7, diabetes, 69,000. Number 8, the kidneys, nephritis, 50,000. Number 9, influenza and pneumonia, 50,000. And number 10, intentional self-harm, i.e. suicide, 38,000. Causes. Consumer Reports, last month's issue, May 2014 issue, medical errors linked to 440,000 deaths per year. That's disturbing. In a recent Floydcast, I talked about infant mortality, with the U.S. ranked number 34. In the U.S., 5.4 children in 1,000 don't make it to their first birthday, even though the U.S. is the country with the most fluoridation, most vaccines, and most money spent on medicine and dental prevention, in quotes. With 3.952 million babies born in the U.S. in 2012, an infant mortality rate of 5.4 translates to 21,345 American children a year not making it to their first birthday. How can this be? Something is causing the ultimate harm to our children. What is it? Or what are they? So it's time for the scientific method. There are many different ways to measure harmfulness. Let's define some common terms first. MCL. MCL is the maximum contaminant level, and there are standards that are set by the EPA. An MCL, quote, is the legal threshold limit on the amount of a substance that is allowed in public water systems under the Safe Drinking Water Act, according to Wikipedia. So the MCL is important in that it governs the bad stuff in our drinking water. But the MCL is unimportant, i.e. not applicable, when it comes to things other than drinking water. Let's move on. LD50. In toxicology, the median lethal dose, LD50, abbreviation for lethal dose 50%, and then there's an LC50, lethal concentration 50%, or there's an LCT50, lethal concentration and time. These are all ratings for a toxin, or a radiation, or a pathogen, and it's the dose required to kill half the members of a tested population after a specified test duration. This is one of these concepts that's easily illustrated with a graph. And I've done that here. Basically, as you increase the amount of a toxin, more and more are affected. Eventually you reach a 50% point. And then even when you keep increasing the toxin, as we find out with cockroaches and whatnot, when we try and poison them, some of them never die. And so then you have a tailing off effect. So the LD50 allows you to equate toxins. One drawback is that the LD50 is a very rough rule of thumb. You can learn more about the toxicology concepts, and there's an informative table on the link I provided. The NOEL, N-O-E-L. This page has a more nuanced take on the subject of the NOEL, including the following quote. The NOEL, or no observable effect level, is the highest dose or exposure level of a poison that produces no noticeable toxic effect on animals. In toxicology, residue tolerance levels of poisons that are permitted in food or in drinking water, for instance, are usually set from 100 to 1,000 times less than the NOEL to provide a wide margin for safety for humans. Well, this is more like it. The NOEL is a great measurement. And once again, with a curve, we can see that the NOEL kicks in at the earliest stage in the curve rather than at the midpoint. But unfortunately, many things in our lives are present at levels much higher than the NOEL. What do we do then? Back to the LD50. It is fitting in this war-driven world that we end up with the LD50, the dose that kills half the test subjects, as the ideal measurement unit. The twist I will put on the LD50 is to use it to compare one toxin to another, to equate poisons, allowing you to pick your toxin, adjust your dose. The 100 times rule in action. So let's look at harmful things commonly found in our environment. We're going to use a color scheme throughout this document. If you see a sort of a dark, rich green, then that means that the substance at the level that we are normally exposed to it passes our toxicology gut check. If you see a sickly green, a green-yellow, that means that it's barely passing, technically passing, but be careful. Yellow means it's exceeding our guideline, and you should, if you're going to continue to use it cautiously. Orange, way above the guidelines, and you should probably avoid this. And then red, you're heading towards the fatal level of something, and you've got to avoid this. So we have an index of all the different compounds from acesulfame, potassium through W's for wireless on this list, and you can just click on an item and go to that item if you wish, but we're going to go through sequentially. In presenting this information, a lot of effort has been put into making it, number one, easy to read at a glance with the color coding. Number two, easy to access in different ways with jump to sections. Number three, easy to put toxins in perspective. The increasing toxicity section at the bottom is especially helpful here. Number four, natural sorting of the document by how easy it is to avoid a toxin. As we progress through this document, the toxins become harder and harder to avoid. Candles and old lace. In 1973, the EPA administrator urged a mandatory ban on all candles with lead-containing wicks. As a result, a voluntary ban was approved, but then not complied with or even monitored. A 1974 EPA study found that burning 2 candles a day in the home increases exposure to airborne lead by a factor of 5 or more. The EPA determined that burning candles with lead-containing wicks exceeded the current EPA air quality standard by over 10 times. And I linked to a page that lists the 1978 lead standard, and it was 1.5 micrograms, millionths of a gram per meter cube. Working backwards and doing a few calculations, I come up with a lead dose from those candles in that room of 217 micrograms. The LD50 for lead is 450 milligrams per kilogram. All the LD50 calculations will sort of start out in this way, where we have a milligram per kilogram type of number, and then we're going to assume an 80 kilogram adult throughout this calculation. 80 kilograms translates to 176 pounds. So when we multiply an LD50 for lead of 450 milligrams per kilogram times 80 kilograms, we get a whole body LD50 dose, a maximum dose that will kill half the subjects of 36 grams of lead. That's over an ounce of lead. So how does our candle-lit dinner factor into that? It's about 0.0006% of lethal. And it's green, dark green, rich green. In other words, it doesn't seem to be a factor. I have another quote in February 2000, Public Citizens Health Research Group. This is now like a decade later. They studied candles in the Baltimore, Washington area. They selected 11 chain stores and dollar store to represent the places where candles are most commonly purchased. 30% of the candles contained metallic wicks. 10 had metallic wicks containing lead. Well, by comparison, fluorine is more toxic than lead, and yet it's available in doses up to 2,100% of lethal, as you'll see below. So if lead-wicked candles concern you, fluoride should concern you approximately 3,483,871% more. Next section. Soda pop. Soda pop is one of the most easily avoided things we consume. We will ignore caffeinated sodas in this section as we cover caffeine later on. First type of soda we're going to cover is using sucralose to sweeten. Sucralose is a chlorinated sugar. I've included a diagram of it. You can see in the diagram the 3 chlorine atoms in the molecule. So it's a man-made, somewhat sugar-like compound. The 3 chlorine atoms in this compound are the same atom found in bleach, mustard gas, and dry cleaning fluid. They're having cases of people drinking 2 liters of soda per day, or 2 quarts a day, for 15 years. But one person with a 3 liter a day habit, that seems to have been too much. I've linked to that tragic story. Well, let's drink 3 liters of sucralose soda, that's about 100 ounces, and find out what the numbers are. The LD50 of sucralose is 10 grams per kilogram. Multiplying by our 80 kilogram person, we would get 800 grams. That's 1.5 pounds of sucralose. The amount of sucralose in a soda depends on the soda, but it's up to about 40 milligrams per 12 ounces. 40 milligrams divided by 80 kilograms yields a dose of 0.5 milligrams per kilogram from drinking 12 ounces of soda. When we compare 0.5 milligrams to the LD50 of 10 grams, we get from one sucralose soda, it's 0.005% of lethal. Again, solid green stuff, nothing to worry about from the LD50 perspective. That person with the 3 liter per day soda habit, assuming it was sucralose soda, then the hit they were taking, the LD50 they were taking from the sucralose in that soda, would have been 0.04%. And again, solidly green, nothing to worry about. In other words, if they ran into a problem, according to this calculation, it wasn't from sucralose. Know your chlorinated sugars. Here's some trivia about good old sucralose. Quote, sucralose is the only chlorinated compound approved for human consumption. Quote. Another quote, some adverse effects were seen at doses that significantly exceeded the estimated daily intake of 1.1 milligrams per kilogram per day. Well, for the 3 liter per day person, the estimated daily intake, if they were 80 kilograms, was about 338 milligrams divided by 80 kilograms, or more than 4 milligrams per kilogram per day. In other words, that's almost 4 times higher than the level where you would see adverse effects. And also working backwards from the level they say is okay, well, that equals about 88 milligrams of sucralose per day for our 80 kilogram individual, which is about 26 ounces of soda, less than 1 liter. A lot of people are drinking more than this. According to the Canadian Diabetes Association, the amount of sucralose that can be consumed over a person's lifetime without any adverse effects is 9 milligrams per day per kilogram. Let's note that 9 milligram per kilogram per day safe figure is over 1,000 times smaller than the LD50. So that's good. But the 3 liter per day person was consuming half of that. So 2,000 times below LD50. What happened to them? NutraSweet. Where's the Nutra? Aspartame, also called NutraSweet, is a very popular artificial sweetener. Sucralose is gradually taking market share away from aspartame, in part because sucralose is 3 times sweeter than aspartame. Aspartame is a complicated molecule. As the picture above shows, there's a benzene ring in there. Generally, you don't want benzene in things you drink. And there's the faintly blue amide groups in this compound. So it sort of highlights the artificial aspects of this Frankensugar. Let's drink 3 liters of NutraSweet soda. The LD50 for NutraSweet, according to NutraSweet.com, is 5,287 milligrams per kilogram, about 5 grams per kilogram. Multiplied by our 80 kilogram person, you're up to 1 pound of this stuff for a person. Cancer.org says one soda usually contains about 180 milligrams of NutraSweet. If we take 180 milligrams, we divide by our 80 kilogram person, that dose is 2.25 milligrams. So 1 NutraSweet soda is 0.04% of lethal. That's a solid green, nothing to worry about number. Now the 3 liter per day person, if they were drinking a NutraSweet or an aspartame soda, then that gives us a 0.36% of lethal. And now that starts to, for the first time, get us from solid green into green yellow. In other words, if it was a NutraSweet soda and he or she was drinking 3 liters per day, that might have had an effect. Just the sweetener component. We have a new sweetener now called Sulfame K, or Sulfame Potassium. It's basically, it seems to be an aspartame clone. I mean, it looks very different as a chemical compound, but it's basically the same strength. And Wikipedia says that Sulfame Potassium is as sweet as aspartame. And by the way, the K in that name is the chemical symbol for the element potassium. And in the picture shown, it's that purple disconnected ball. Basically what that means is when you take Sulfame K and stick it in water, the K, the potassium, dissociates or dissolves in the water and moves independently from the molecule itself. This Sulfame, in the main molecule, there's a sulfur atom shown by a gold ball in the picture. And this is a clue that we have left the land of natural sugar compounds. With an LD50 of 7,431 milligrams per kilogram, it has a similar toxicity to aspartame. I tried to find the amounts of the stuff used in sodas. I was unable to find it, so We mention it here so that you will recognize this new artificial sugar when you see it on food and beverage labels in the future. Energy drinks for your daily commute. While many drinks could be considered energy drinks, today the category is defined by names like Red Bull, Rockstar, Monster, and relative newcomers like 5 Hour Energy. If the commercials are to be believed, Gatorade created the category somewhat by accident. An unappealing drink was handed out on the sidelines of football games. Containing more than just water and oranges, it became the Florida Gators' worst-kept secret. Salt, the sodium chloride form, was the first addition to replace some of the salt lost due to sweat. Overrated drinks. As science got more involved, things like potassium, another essential body ion, were added. As nutritionists and sports scientists got involved, they found that fluid replacement drinks were only needed after the most extreme exercise. Quote, exercising 1.5 to 3 hours is long enough to warrant fluid replacement due to sweat losses. Quote, breakfast of champions? Some years back I worked for the city, performing yearly tests to ensure that thousands of fire hydrants were still functional. The water department's main waiting room, you spend a lot of time waiting when you work for the city, was where I first saw people drinking Gatorade before going to work. There was even a special product for just this purpose, Gatorade AM. The revolution or evolution has continued. Gator Offspring. Gatorade now has a G series. There's a before drink. The during drink is, I think, pretty much the same as it used to be. And then there's an after drink that I believe also has some protein in it. The idea being you might damage your muscles, or in exercising your muscles want to rebuild in some way, and so then having protein in the drink. It seems entirely reasonable to me. But then there are the more radical energy drinks. Perhaps pioneered by Red Bull, there are now dozens, if not hundreds, of energy drink variations. Let's look briefly at a few of them. Rock stars are not monsters. Red Bull, in its rather small 8.4-ounce can, has 80 milligrams of caffeine and 27 grams of sucrose and glucose. Their website describes the sugar as about equal to that present in 8.4 ounces of orange or apple juice. It also has a gram of taurine and some B vitamins. Rockstar energy drink doubles these numbers, with 160 milligrams of caffeine, 63 grams of sugar, and apparently one source said that was equal to 2 Snickers bars worth of sugar. And this is all in a 16-ounce can, so the can size is also doubled. Monster energy drink comes in 16 and 24-ounce cans. I found the Monster website unhelpful in coming up with an ingredient list, so I'll use the list on Wikipedia. Drinks of B12. Wikipedia says you should figure 10 milligrams per ounce of caffeine for Monster energy drinks. So for a 16-ounce can, that would be 160 milligrams of caffeine, with the 24-ounce can having 240 milligrams caffeine. The ingredients listed for Monster energy drinks on Wikipedia is as follows. Carbonated water, sucrose, glucose, citric acid, natural flavors, taurine, sodium citrate, color added, Panax, ginseng root extract, L-carnitine, caffeine, sorbic acid, benzoic acid, niacinamide, sodium chloride, glucuronolactone, inositol, guarana seed extract, pyridoxine, hydrochloride, sucralose, riboflavin, maltodextrin, and cyanocobalamin. Well, cyanocobalamin is vitamin B12. Potentially lethal energy drinks. The Caffeine Informer website is helpful for learning more about energy drinks. Getting to the heart of the matter, an energy drink can be a heart stopper. Sadly, there have been enough cases to launch investigations and even lawsuits. The problem comes from things like energy shots that have more caffeine than the 10 milligrams per ounce ratio that energy drinks originally adhered to. That's some high-test hooch. Monster Espresso, for example, is a 6.8 ounce product, but instead of having 68 milligrams of caffeine, i.e. 6.8 times 10, it has 221. Redline, an 8 ounce drink, has 316 milligrams of caffeine. This is 4 times the caffeine of a similarly sized Red Bull. The 5 Hour Energy shot comes in a 2 ounce container, but instead of 20 milligrams of caffeine, it has 200. 5 Hour says this is about as much as a cup of premium brewed coffee. Well, that's true enough, but the caffeine in the shot is 4 times more concentrated. Caffeine delivery vehicles. Some energy potions have even more caffeine per ounce, making them basically liquid caffeine pills. Let's compare them to NoDoz. No-dose are caffeine pills. The box says safe as coffee, and no-dose maximum strength contains 240 milligrams of caffeine. The strongest liquid caffeine drink I could find is Energy Catalyst. One shot of this is a mere quarter of an ounce, a teaspoon and a half. Delivering 100 milligrams of caffeine, this works out to 434 milligrams caffeine per ounce. Basically, a cup of coffee per tablespoon. And here is where a new problem emerges. Bartender, energy shots for everyone. It has become popular to mix energy drinks with alcohol. Medically, alcohol is a downer. Energy drinks are an upper. One cancels the other. Almost makes sense, right? Well, alcohol is a downer in part because it is a poison. Caffeine, quote, a bitter white crystalline xanthine alkaloid, quote, is also a potent toxin. So what normally saves the average person from caffeine problems? Experience. Observing the cause and effect from something as minor as an extra late-night cup of joe is usually enough to make us think twice before doing it again. A scientist walks into a bar. Bar patrons are not known for their scientific pursuits. Alcohol impairs judgment, as does youth. It is one thing to drink a Red Bull with your beer. It's quite another to use energy shots as drink mix. When you do that, every drink of alcohol delivers up to 242 milligrams of caffeine. For a 110-pound student, the percent of lethal hit from 242 milligrams of caffeine in a 2-ounce energy shot equals the percent of lethal hit from the ounce of hard liquor, as we'll see below. Wow. Caffeine and poison both have an I in them. The American Association of Poison Control Centers tracks all the calls they receive from intentional or accidental overdose of all kinds of substances and drugs, including caffeine and energy drinks. The AAPCC took 4,265 calls that involved caffeine poisoning. I think that was in 1 year, I forget the year, but recently. About 3 in 10 of those involved energy drinks. They gave the name of this page, A Real-Life Death by Caffeine. Next section. Swimming in chlorinated water. Energy shots can be avoided. Trying to avoid a chlorinated swim is not so easy. The toxicity of chlorine comes from its oxidizing power. When chlorine is inhaled at concentrations above 30 parts per million, quote, it begins to react with water and cells, which change it into hydrochloric acid and hypochlorous acid, quote. The target amount of chlorine in swimming pools is 1 to 3 parts per million. Well, at 3 parts per million, the free chlorine in a pool is just 1/10 of what it takes to form hydrochloric acid in your lungs. The safety factor of being less than 1/100th of the no observable effect level is not being observed. I've linked to something by Dr. Mercola, who weighs in on the pool chlorination situation. Basically, with the information I was able to get, I say that one swim in chlorinated water gives you 10% of the harmful dose. Not the lethal in this case, but the harmful dose. Swimming in chlorinated fluoridated water. Yes, you could be swimming in chlorinated fluoridated water. All it takes is for your pool to be in a fluoridated water area. Let's dip into the fluoride section below, where we find the LD50 of fluoride is 50 milligrams for a 22-pound child, i.e. 10-kilogram child. I found a story of a person who systematically weighed themselves before and after each swim, and they found that they absorbed 7 to 10 pounds of water per swim. There's 454 grams in a pound, 1 part per million fluoride. That works out to 3.5 to 5 milligrams of fluoride absorbed per swim. Scaling for the 15 times lighter 22-pound child, we get about a half a milligram of fluoride absorbed in a swim. So one swim with water that's not bleached, just fluoridated water, would be 1% of lethal to that 22-pound child. Plus, that one swim in only chlorinated water would be 10% of harmful. For a total effect from one swim in bleached fluoridated water of more than 10% of harmful to that child. These are solid orange numbers, orange results. Pharmaceuticals. Helping me, right? ASA. As safe as... Acetylic acid, also called aspirin, is somewhat like a glass of wine a day. It's something we have been repeatedly told is GOOD. The LD50 for acetylsalicylic acid is 1,750 milligrams per kilogram. 1,750 milligrams kilogram times 80 kilograms yields an LD50 of 140,000 milligrams, or 140 grams, about a third of a pound. One pill contains 325 milligrams. When you work out the percent of LD50, the percent of lethal, we get 0.23 of 1%. And so that puts us in the green-yellow area. Not ideal, but probably nothing to worry about by itself. What about a baby aspirin? A baby aspirin is 1/4 the milligrams of an adult aspirin, but we're going to work out the effective dose for a child, right? Because that's the worst case scenario. Well, one baby aspirin produces 0.5 of 1% of lethal. Again, green-yellow results. No ASA in my bathroom cabinet. I don't know about healthy, but it appears the suggested doses of aspirin are low enough to pass our toxicology gut check. But how do you feel about bleeding under the skin? Acetylsalicylic acid has a blood-thinning property. For medical types, this is considered a good thing. Pop a pill, thin your blood, reduce your chance of having a stroke, pure win. Well, next time you see an older person with purple to black discoloration of the skin on the back of their hands, just ask them if they take a blood thinner. Interesting that when I typed bleeding under the skin and bleeding under the hand into Google Images, it didn't show almost any pictures of this particular type of bleeding. I counted 1 out of several hundred that I looked at. Your mileage may vary. You can never accuse the medical profession of wanting to air their dirty laundry in public. Ibuprofen, the only useful drug? The LD50 for ibuprofen is 636 milligrams per kilogram. For our 80 kilogram human, the LD50 would be 50,000 milligrams. The maximum prescribed dose of ibuprofen is 3,200 milligrams per day. But for most of us, normally, we take one pill, and normally that one pill is 200 milligrams. Those are the ones that I've got anyway. A 200 milligram ibuprofen gives you 0.39 of 1% of lethal. So it's green-yellow stuff. Not ideal. Now, if you went for that maximum recommended dose, 3,200 milligrams per day, that would give you 6.3% of lethal. Well, this is solid yellow material. So I have ibuprofen in my bathroom cabinet, it's in our first aid kit, and I have it in my truck. But I take, at most, 1 pill of it, the weakest strength, per year. I view moderation. I don't believe in taking drugs regularly. Take ibuprofen and ibuprofen alone because it can do something that sometimes I think needs doing. Reduce swelling. But these are drugs after all. They work, typically, by doing something bad. They're a trade-off at best. They always produce side effects. Ibuprofen, for example, affects your kidneys. By the way, that kidney link suggests the maximum prescribed daily dose is 2,400 milligrams. I'm not a doctor. I'm not recommending a dose, but I will say use as little as possible for this and all drugs. If you wish to be healthy, work on your health in healthy ways. Slow burn. My most common side effects whenever I research drugs are increased stomach acid, higher blood pressure, and a need to do some deep breathing. It greatly frustrates me that side effects are routinely ignored, while doctors prescribe drugs that allegedly might, if you believe the only 2 studies that were favorable, help you. Let's dig a little deeper into the corrupt world of drugs. Paracetamol. Pain relief? Paracetamol is also known as acetaminophen, and it's, quote, commonly used for the relief of headaches and other minor aches and pains, and is a major ingredient in numerous cold and flu remedies. Well, since, quote, liver failure has been observed at doses as low as 6 grams per day, quote, we'll take that as our LD50. The maximum daily dose of acetaminophen is 4 grams. TylenolProfessional.com says a dose is 1 gram or 1,000 milligrams. So a single 1,000 milligram paracetamol is 16.6% of lethal, or of inducing liver failure in some people. And a day's maximum dose of paracetamol is 2/3 of the lethal, 2/3 of liver failure inducing. Those are orange and red numbers. By the way, did that sound like a solution? Doctors recommending 3 or 4 grams a day and 6 grams has caused liver failure. The range of concerns and list of side effects from paracetamol are pretty substantial. Personally, I strictly avoid taking pills to manage pain. I found that trying to work on the cause of the pain and managing chronic pain with breathing and other healthy living measures is my best bet. Antacids. Antacids are complex and varied products. I found 3 incorrect formulas in Wikipedia's list of antacid chemicals. The second sentence in the indications section on that Wikipedia page is also worth noting. Quote, treatment with antacids alone is symptomatic and only justified for minor symptoms. Basically, if you take antacids regularly, you can end up with too much calcium in your body, or a too basic condition, where basic is the opposite of acidic. The milk alkali page on Wikipedia covers this in more detail and also mentions that, quote, ingesting over 2 grams of elemental calcium per day produces this disorder in susceptible individuals. So 2 grams a day is harmful. We'll make a note of that. Antacid, Alka-Seltzer. In trying to find out the usual dose, I clicked the first antacid listed, and it happened to be Alka-Seltzer. No dose was mentioned on Wikipedia's Alka-Seltzer page. Drug companies are always encouraging you to see your doctor, etc. They don't want to be guilty of recommending a dose, then for you to have harmful effects from that dose. Does that sound healthy or health-inducing? Anyway, Amazon.com appeared to have less reservations. Alka-Seltzer page on Amazon begins with a safety warning that lists about 50 side effects and cautions. It then lists the ingredients. Anhydrous citric acid, 1000 milligrams, dash antacid. Aspirin, 325 milligrams, dash analgesic. Sodium bicarbonate, heat-treated, 1,960 milligrams, so that's about 2 grams, antacid. And non-steroidal anti-inflammatory drug. They don't specify. Since Alka-Seltzer contains 325 milligrams of aspirin, which by the way I believe is the adult dose, we can calculate an LD50 for that. In fact, we already have. 1 aspirin, as part of your Alka-Seltzer, is 0.23% of lethal. In 1 effervescent tablet, as they describe Alka-Seltzer, it also contains 2 grams of sodium bicarbonate. The LD50 of sodium bicarbonate is 4,000 milligrams per kilogram for a rat. When we convert, it turns out the LD50 for an 80 kilogram person is about 337 grams, or about 3/4 of a pound. So 2 grams of sodium bicarbonate is about 0.59% of lethal. The non-steroidal anti-inflammatory, well, it's an unknown effect. They don't say how much of it there is, and they don't say what the drug is. Now, to not appear to be picking on any one brand and to show the wide chemical variation in these antacid products, I'll review a few more. Antacid, Maalox. Maalox is calcium carbonate, CaCO3. And the Wikipedia page for calcium carbonate says it is commonly used medicinally as a calcium supplement or as an antacid, but excessive consumption can be hazardous. I also thought this sentence was worth a read. Quote, during the past 15 years, milk alkali syndrome has been reported in women taking calcium supplements above the recommended range of 1.2 to 1.5 grams daily. Well, where's the safety factor? What I find puzzling is that a problem is reported when taking calcium carbonate above a recommended range with no quantitative measure mentioned. There's no mention of being 100 times more than a recommended range or just above. So how far above is anyone's guess. Anyway, we'll use our percent of LD50 analysis. Calcium carbonate has an LD50 of 6,450 milligrams per kilogram for a rat. Multiplied by our 80 kilogram person, we get 516 grams. That's over a pound. So 1.5 grams of calcium carbonate in Maalox is 0.29%. Green, yellow stuff, all this. Mylanta as an antacid. Wikipedia's Mylanta page lists 3 ingredients in Mylanta: aluminum hydroxide, magnesium hydroxide, and simethicone, which is, quote, an anti-foaming agent used to reduce bloating, discomfort, or pain caused by excess gas. Aluminum hydroxide has an LD50 of 5,000 milligrams per kilogram in a rat. When you multiply 5,000 milligrams per kilogram times 80 kilograms, you get about 400 grams, 90% of a pound. Regular strength Mylanta has 200 milligrams of each of aluminum hydroxide and magnesium hydroxide, and 20 milligrams of simethicone. Let's take these individually. 200 milligrams of aluminum hydroxide is 0.05 of 1% of lethal. Magnesium hydroxide, the LD50 is 2780. When you work it out for our 80 kilogram person, the LD50 body dose would be 222 grams, or about half a pound. So the 200 milligrams of magnesium hydroxide in 1 dose of Mylanta is 0.09 of 1% of lethal. And then I've included a picture and the formula for simethicone. It's got silicone in it. I guess that's chemically what I would say is noteworthy. In fact, honestly, it looks like the silicone is in place of where you normally see carbon atoms. Silicon is chemically similar to carbon, for what it's worth. It's 1 stage up in size. It's like chlorine is chemically similar to fluorine, only 1 stage up in size. Simethicone has an LD50 of 980 milligrams per kilogram times 80 kilogram person gives you 78 grams, or about 3 ounces. 20 milligrams of simethicone works out to 0.03 of 1% of lethal. So all these are green results. Caffeine, the most loved drug? Even though caffeine appears to be easily avoided, the combination of it being mildly addictive and it appearing in literally thousands of products makes it something we have grown to expect in our lives. One of the pages I found, for example, listed several hundred caffeine-containing candies. There are similarly hundreds of caffeinated sodas, and chocolate bars, and different types of coffee, and tea. Sadly, caffeine does have an LD50. The LD50 for caffeine is 150 to 200 milligrams per kilogram, and they say that that's about 80 to 100 cups of coffee for the average adult. This makes caffeine about 25 to 66 times more toxic than aspartame or sucralose. An LD50 using the 150 milligram per kilogram figure times our 80 kilogram adult works out to 12,000 milligrams or about 12 grams. Our personal doses vary substantially. Fortunately, the mighty Mayo has weighed in on the subject. I've given a link to a story they wrote about it. Well, let's brew some medicinal Joe and then crunch some numbers. One brewed 8-ounce coffee, 1.67% of lethal. That's yellow. Returning to our soda pop calculations for the 3-liter per day person, using 55.5 milligrams of caffeine per 12 ounces, times the 100 ounce, we get that this person was consuming 469 milligrams of caffeine per day. Well, that works out to 3.9% of lethal. Coffee refill, anyone? Over the years, the suggested limit I have most commonly seen is 4 to 6 cups per day. Well, 6 brewed 8-ounce coffees works out to 10% of lethal. And then I have to color that orange. So that's too close to a coffee-colored result. Meet my friend Pete. Personally, I have settled on a single coffee in the morning, admittedly at twice the size of our 8-ounce test cup. So my one brewed 16-ounce coffee is 3.33% of lethal. Did I mention my coffee strategy includes periodically going off it, sometimes for years at a time? Caffeine-drug interactions. While researching caffeine side effects, I stumbled across an interesting tidbit. Quote, drugs such as fluvoxamine or levofloxacin can have a similar effect by blocking the liver enzyme responsible for the metabolism of caffeine, thus increasing the central effects and blood concentrations of caffeine 5-fold. Interesting that both these drugs are fluorine based. Nicotine. Smoke, gum, or chaw. Nicotine comprises up to 3% of a tobacco leaf. An average of 1 milligram is absorbed from smoking 1 cigarette. The LD50 for humans is 1 milligram per kilogram, making nicotine 2,000 plus times more poisonous than salt, and 7 times more toxic than cocaine. 1 milligram divided by 80 kilograms yields a dose of 0.0125 milligrams per kilogram. So 1 smoked cigarette is 1.25% of lethal. Smoking a pack of cigarettes, 25% of lethal. Observation. In order to safely dose yourself with cigarette smoke, only 1 cigarette at a time should be smoked, when considering the toxic effect of the nicotine alone. By the way, pound for pound, nicotine is 100 times more deadly than alcohol. Quote, nicotine has a relatively high toxicity in comparison to many other alkaloids, such as cocaine. Nicotine from eating a cigarette. Wait, why would you eat a cigarette? Imagine you spend your days walking around on all fours, biting table legs, and drooling. Kids eat the darndest things. The average cigarette contains 9 milligrams of nicotine. If you eat it, your intake is all 9 milligrams. 1 milligram per kilogram is enough to kill. 9 milligrams could kill a 9 kilogram, i.e. 20-pound child. 81 milligrams, 9 cigarettes, could, in theory, kill an adult. So 1 swallowed cigarette is 100% lethal for a 20-pound child. In selecting pictures for this research paper, I typed into Google's images search, baby smoking, I think, or baby and cigarette is what I typed. And they had all too many pictures of babies with cigarettes in their mouths, and some of them, in the pictures, the cigarettes were lit. I decided not to include any pictures. The nicotine-MRSA connection. MRSA, MRSA, is methicillin-resistant Staphylococcus aureus. Found an article that makes the connection between nicotine and MRSA. Quote, smoking weakens the immune system and lowers the ability of human cells to fight infection. Smoking cigarettes and breathing in secondhand smoke puts people at risk for developing severe lung and respiratory tract infections. Smokers are 2 to 4 times more likely to develop pneumococcal pneumonia than non-smokers. Cigarette smoking also increases the rate and severity of influenza infection and increases the risk of tuberculosis. Well, it seems that 20% of the population are MRSA carriers. MRSA most commonly lives in the nasal passages, and nicotine, quote, induced resistance to antimicrobial peptides, quote, the stuff our bodies make to kill bacteria like MRSA. Smoking. 7,000 chemicals can't be good. The CDC says smoking, quote, harms nearly every organ of the body, quote. The National Center for Biotechnology Information, NCBI, says there are human inhalation risk values for 98 components of cigarette smoke, including 9 known human carcinogens. In another report says cigarette smoke contains over 4,700 chemical compounds, including 60 known carcinogens. There's also a non-trivial amount of radioactive stuff in cigarette smoke. Quote, smoking an average of 1.5 packs per day gives a radiation dose of 60 to 160 millisieverts per year. Living near a nuclear power station is about 1 million times less than that. So when you work out the LD50 for one cigarette from not just the nicotine but from all the toxins in cigarettes, we clearly get a value that's much greater than 1.25% per cigarette. I've rated that as orange, but it probably should be rated as red, but technically one cigarette, orange is probably a good rating. Good bad rating. Alcohol, always over the limit. Showed a picture of the alcohol or ethanol molecule. Such a simple and natural molecule. Alcohol is hard for us to handle because the enzyme needed to break it down has to be manufactured in the liver, and the liver only makes enough enzyme to handle about an ounce of alcohol per hour. If you drink faster than that, you'll find yourself accelerating down a toxic road. The average consumption of alcohol is 4 drinks per week. We will assume this translates to 1 drink at a time on 4 separate days of the week. Ethanol packs a punch. The LD50 for ethanol is 7 grams per kilogram. In a single 1 ounce drink of hard liquor, there's 40% ethanol. 40% of 1 ounce times 28.35 grams per ounce, and you get 11 grams of pure alcohol in a 1 ounce shot of hard liquor. 11.34 grams divided by our 80 kilogram person gets a body dose of 0.14 grams per kilogram. So 1 alcoholic drink is 2% of lethal. That's yellow. Drinking a 12-pack of beer, 24% of lethal. Red. Teetotal Tuesdays. Observation. In order to, quote, safely, quote, dose your 80 kilogram body, 176 pound body, with alcohol, only a half of a single drink at a time should be consumed. So much for a glass of wine a day is good for you. A 110 pound college student could die if they drank, by these calculations, 30 ounces of alcohol, or less. Do not try this. Don't even come close to this amount. Alcohol. A gun in the hands of a child. Obviously, it is very undesirable for a child to consume any alcohol. In addition, it is illegal. Still, there are some who do this, just as there are some that give alcohol to pets. The average 1-year-old weighs 22 pounds. 1 ounce of hard liquor to a 1-year-old would be a dose of 1.13 grams per kilogram. That's 16% of lethal. I marked that as red. Don't do this. This is so very wrong. Observation for a 1-year-old child to not suffer from consuming alcohol. 1/16 of a drink at a time should be considered the absolute limit. This is about 1/3 of a teaspoon of hard liquor. So if your child should accidentally consume alcohol, and they consume more than 1/16 of a drink being a beer, glass of wine, or an ounce of hard liquor, you should treat it as an emergency situation and seek medical assistance immediately. The purpose of this section has been to confirm, using the most basic of calculations, that alcohol and children should never mix. Chlorination, bleach in the water. It is recommended that household bleach be added at 200 milligrams per liter to well water. The LD50 of this kind of bleach is 192 milligrams per kilogram. Let's drink 8 glasses of home bleached well water. It's about 2 liters, 2,000 grams. At 200 ppm, we ingest 400 milligrams of chlorine. We'll assume an 80 kilogram person. 400 milligrams divided by 80 kilograms equals a dose of 5 milligrams per kilogram. Comparing that to the LD50 dose, and we get 8 glasses of bleached water is 2.6% of lethal, so it's yellow, which is why I get mountain water. Chloramines, a more stable bleach. There are monochloramines, dichloramine, trichloramine. The di and tri forms are less stable. Chloramine in drinking water standard is set by the EPA, 4 parts per million. 8 glasses of chloraminated water at 4 ppm means we swallow 8 milligrams of chloramine. 8 milligrams divided by 80 kilograms yields a dose of 0.1 milligrams per kilogram. The LD50 of chloramine is 1,400 milligrams per kilogram, but there are many decay products. Some have much higher LD50s. N-nitrosodimethylamines LD50 is 37 milligrams per kilogram for a rat. 8 glasses of chloraminated water, the percent of lethal is 0.007, so that's a solid green. But if it decays into the N-nitrosodimethylaminated form, 8 glasses of that would be 0.27%, a yellow-green result. The number of decay products produced and their much greater toxicity should give you pause about drinking chloraminated water. Also, chloramine is a weaker germicide, but more stable, so they end up using chlorine as well. The EPA talks about liver damage at 200 parts per million, and the NOEL, the no observable effect level, is 50 milligrams per liter. So at a minimum, it is concerning that chloramine is added at a level just 12 times lower than the NOEL level, instead of 100 or 1,000 times lower. Salt. A pinch, but not two. Salt is the ultimate unavoidable toxin because it is essential to human life. As the picture above shows, salt is a uniform crystal lattice. The larger chlorine atoms can be filtered by the kidneys, unlike the much smaller fluorine atom. Salt's LD50 in animals is 2 to 6 grams per kilogram. The average American salt consumption is 3,500 milligrams a day, and it should be half that. 3.5 grams divided by 80 kilograms yields a dose of 0.04 grams per kilogram, and that works out to being about 2.2% of lethal. Remember that rule of thumb that the daily dose should be no more than 1% or 1/100th of lethal dose. The average American is double that. Swedes consume 1/4 of the salt that Americans do, so their 875 milligrams per day is 0.5 of 1% of lethal, so they get the yellow-green status. The Swiss, on the other hand, average over 10 grams per day. Their salt consumption is putting them at the 6.6% of lethal level. Glutamates. Monosodium glutamate is the most well-known of a family of compounds referred to as glutamates. Avoidable in some cultures, they are added like salt in other cultures. The LD50 for MSG is 16.6 grams per kilogram. Bodily LD50 would be 16.6 times 80, or 1,328 grams, which is about 3 pounds. Quote here I have that says, in a clear soup, the pleasantness score rapidly falls with more than 1 gram of MSG per 100 milliliters. 100 milliliters weighs 100 grams, about 250 milliliters in 8 ounces, so 8 ounces of MSG enhanced soup would have about 2.5 grams of MSG. So the MSG in a soup, it's about 0.2 of 1% of lethal. It's a yellow-green. Fluoridated salt equals poisoned salt. Sadly, some countries sell fluoridated salt. A practice started in Switzerland in 1955. Initially, the fluoride poisoning was at a lower level, 90 parts per million. Today, the poisoning ranges from 200 to 350 parts per million. I wonder what the poisoning level will be tomorrow. Even worse, some countries require that all salt be fluoridated. Jamaica, Costa Rica, and Colombia all do this. Borrowing from the fluoride section below, the LD50 is 50 milligrams per kilogram for a 10 kilogram or 22 pound child. Crunching the numbers, the 3.5 gram salt US average per day diet is 2.19% of lethal. But you got to work out the fluoride in that salt, and that's 2.4% of lethal. So when you add the total toxicity of fluoridated salt, you get 4.6% of lethal. And that's a solid yellow one. Our salt miser Swedes, they also end up in the yellow zone. Before, their habit was a green or a yellow-green habit, and now it's with 1.6% of lethal in fluoridated salt, they're getting into the yellow zone. Fluoridated salt takes on the world. Apparently South America has been particularly targeted. In 1996, PAHO pushed a massive fluoridated salt program on Bolivia, Dominican Republic, Honduras, Nicaragua, Panama, and Venezuela. And you can see by the graphic who's being targeted and who's going to be targeted next. Himalayan salt, probably perceived as something of a salt delicacy, is salt contaminated with fluoride at levels of 230 to 310 parts per million. If you make your daily salt habit out of Himalayan salt, you end up with 4.6% of lethal. Solid yellow result. Fluoride, dental toxin of choice. The human body does not need fluoride. Human and animal teeth do not need fluoride. Yet fluoride is one of the most pervasive toxins in our lives. The toxicity of fluoride is well known and studied. I have a number of pages and videos on the subject. Fluoride has its own toxicity page on Wikipedia. Quoting from there, the lethal dose for most adult humans is estimated at 5 to 10 grams. Which is equivalent to 32 to 64 milligrams per kilogram. When a toxin has an oral LD50 of less than 50 milligrams, it is classified as Category 1, the most dangerous category. Anything containing such a toxin requires a skull and crossbones be displayed on the packaging. Well, this is the case for fluoride, because when you take the lower bound of that Wikipedia figure, the lower bound is 32. It takes only 32, a 30th of a gram, a thousandth of an ounce. Right away, we should be scratching our heads as to why something more toxic than lead, almost as toxic as arsenic, is being deliberately added to our drinking water. The lead goblet-using Romans look positively sober by comparison. Drinking your fluoride. 8 cups of fluoridated water, poisoned at the optimum level of 1 part per million. It's about 2 liters or 2,000 grams. By following our doctor's advice, we are diligently and carefully drinking 2 milligrams of fluoride poison with our tap water. With an LD50 of 50 milligrams for a 10 kilogram child, we end up with 4% of lethal just from the fluoride in our drinking water. 4%, yellow result. We're alive, but are we well? It won't kill a 22-pound child to drink 8 cups of poisoned water, but that child is over the recommended limit of at least 100 times less than the NOL by a factor of 4. Quote here from Dr. Gene Burke, in point of fact, fluoride causes more human cancer death and causes it faster than any other chemical. He worked for 34 years at the National Cancer Institute. In short, one part of the government is recommending something that another part of the government says is not a good idea. Declan Waugh has a 166-page report on the health implications of water fluoridation on disease incidence and mortality in the Republic of Ireland, as well as other fluoridated countries. That child's safe dose, by the way, to be 100 times under the NOL, would be just 2 cups a day. But actually, that would be the safe dose of fluorine from all sources, and it's exceeded as soon as that child drinks 2 cups of fluoridated water. But there are plenty of other sources of fluoride, as we shall see. A trip down MCL lane. The EPA MCL, i.e. maximum contaminant level for lead, is 0. 0 parts per million of lead are allowed in our tap water, and rightly so. Yet it is an established chemistry fact that fluoride is more toxic than lead. They put what in our water? It is quite a shock that the EPA MCL for fluoride is 4 parts per million. This value, of course, is highly suspect, since, quote, the maximum permissible level of a contaminant in water is set as close as possible to the level at which no adverse health effects occur, quote. Worse than pointless. The U.S. Center for Disease Control has a state-by-state database showing the percent of residents who are fluoridated by state, and it categorizes on this graph high-income and low-income results of whether their teeth are considered very good or excellent. And basically, the bottom line is no matter what the level of fluoridation, the quality of the teeth is completely unaffected. State by state, 51 results or 50 results shown here. Definitive text counsels caution. Consulting my 2,350-page 56th edition of the Handbook of Chemistry and Physics, the single most authoritative and comprehensive book on matters chemical, I read, the presence of fluorine as a soluble fluoride in drinking water to the extent of 2 parts per million may cause mottled enamel in teeth. Mottled enamel is a good thing for the dental industry, then they can sell you caps and things like that for your teeth. But in addition, mottled enamel is an observable effect of fluoride. So that sets the NOL at 2 parts per million or lower. Applying our first principle of toxicology, we immediately realize that the 1 part per million optimal level is in fact 50 times too high. And this is before we consider other sources of fluoride poisoning in our environment. Fluoridated showering. Clean is relative. 1 pound of water is absorbed in a shower. 454 grams in a pound. At 1 part per million fluoride, that translates to half a milligram of fluoride just from a shower. And so 1 fluoridated shower gives you 1% of the lethal dose of fluoride. Green tea, not so refreshing. Green tea has 1 to 5 parts per million fluoride. So 1 cup of green tea can equal 5 cups of fluoridated water. That works out to up to 20% of the lethal dose for a child. 1 cup of tea. Of course, 1 cup of green tea made with fluoridated water equals 6 cups of fluoridated water. And that puts you up to 24% of lethal. We're now into the red zone for that 22-pound child from 1 cup of green tea in fluoridated water. I show a graphic here where some other authorities found higher levels than I've quoted for the amount of fluoride in tea. Some actually extremely alarming levels. I'll just quote one of the results. 1 tea bag, Andreas Schuld found the average of commercial green and black teas 1 tea bag steep for 5 minutes, 8 ounces of tea. They tested and found 20 milligrams of fluoride on average. So that one 8-ounce cup of tea with 20 milligrams of fluoride, the average cup of tea, according to them, was 40% of lethal. Toothpaste, tickling your ivories. Toothpaste is about 1,000 parts per million fluoride, but some brands have much more. ClinPro 5000 contains 5,000 parts per million fluoride. Incidentally, a 6-ounce tube of regular strength fluoridated toothpaste contains 45 milligrams of fluoride, with 50 being enough to kill a 22-pound child. Even a pea-sized amount of ClinPro 5000 weighing just a quarter of a gram results in 1.25 milligrams of fluoride going into your mouth. Some dentists recommend more than a pea-sized amount. This dentist that I quote recommends a 1 gram amount. Following that advice, and you put 5 milligrams of fluoride in your mouth in one go when you brush. If you swallow just 10% of that, you have consumed 0.5 milligrams of fluoride. So one fluoride brushing is 1% of lethal for a child. And a 22-pound child eating a tube of yummy bubblegum-flavored fluoridated toothpaste, well, that's about approximately 100% of lethal. In other words, half the kids doing that, 1-year-olds doing that, will die. Between 1990 and 1994, 4-year span, 628 people received an overdose of fluoride from their toothpaste. It's one every other day. You may not be aware of this. Time to stock up. You can get bacon-flavored toothpaste. And you can also get sweet cupcake frosting flavor toothpaste. No exaggeration. Fluoride pills. Thank your school nurse. Fluoride drops. If ever something was descriptively named, this is it. Sodium fluoride chewable tablets contain 0.25 to 2.5 milligrams of fluoride. So one 2.5 milligram fluoride pill is the equivalent of drinking 10 cups of fluoridated water. That's 5% of lethal. Should schools be giving children 5% of a fatal dose of anything? FluorideAlert.org had an image over top of a picture of a bottle of fluoride chewable tablets. They have the stamp saying not approved. Probably worth researching. School poison brought home. In 2010, the American Dental Association's Council on Scientific Affairs announced its recommendation that fluoride supplements should only be prescribed for children who are at high risk of developing caries. Well, how is one to know if they are at high risk? And I've shown a label here from these fluoride chewable tablets. Here's the ingredients. Obviously the fluoride. Inactive ingredients: lactose, which is milk sugar; saccharin, which is an artificial sweetener; grape flavor, so you have poison that's sweetened and grape flavored. Also, given that fluoride drops are not to be used when one is also being carefully poisoned with fluoridated water, how does a school keep track of who is and isn't being poisoned at home? My international anti-fluoridation database keeps things relatively straight, but it is routine for those on one side of the street to be poisoned while across the street they are not. Do you know which side of the street you're on? Mouthwash, killing more than germs. Mouthwash is up to 0.2 of 1% sodium fluoride, and fluoride would be 40% of that sodium fluoride compound. We'll assume for the moment that you try to spit it out and end up absorbing just 10% of your mouthwash. For 1 ounce of mouthwash, it's 28 grams. You do the math, 2.2 milligrams of fluoride you're ingesting. Unfortunately, children and patients under one's care are not quite so careful about spitting out their mouthwash. That 1 ounce of fluoride mouthwash, where you spat out 90% of it, 4.4% of lethal for a 22-pound child. Drinking 1 ounce of mouthwash, i.e. you don't spit out any of it, is 44% of lethal for a 22-pound child. That means you're halfway to half the children dying by drinking 1 ounce of fluoride mouthwash. Fluoridated mouthwash is available in sizes. The biggest size I've seen is 1.5 liters, quart and a half. If you drink that whole thing, now obviously that's a lot, but if you drank that whole thing, that would be 2,100% of lethal. In other words, that's 21 times more than you need to kill half the test subjects. Just 4 ounces of mouthwash is enough to kill a 5-year-old child. Sulfuryl fluoride. Fumigate. SF2, used to fumigate foodstuffs so they won't be healthy enough for bugs to eat, is unregulated. This in itself is mind-boggling. I got a quote here from homeopathyworldcommunity.com, and they say fluoride is neurotoxic. Will the American people let the EPA allow sulfuryl fluoride, a highly toxic food fumigant and potent greenhouse gas, in the food supply? Well, of course they will. And the level of that fumigant? Well, 12.5 parts per million fluoride in brown rice. 4.5 parts per million in white. With an average portion size of rice of 3 ounces, you're eating 1 milligram of fluoride. If you like almonds, they have 5.3 parts per million fluoride. 3 ounces of fluoride fumigated rice then is 2% of lethal for that 22-pound child. Sulfuryl fluoride hearts the Farm Bill. The Farm Bill, passed through the Senate this year, 2014, increases the allowable levels of sulfuryl fluoride fumigant used in foods from 7 parts per million to at least 70 parts per million in 99% of all processed foods, and 125 parts per million in wheat flour, and 900 parts per million in powdered eggs. I'm going to go out on a limb here and estimate that the reason that it's so high for powdered eggs is that egg shells get into the final product and they just blend it up so that you don't notice. But the shells, the calcium of those shells, just like in your bones, that's where the fluoride ends up. So that's why those shells are loaded in fluoride, so they had to jack up the allowable level for powdered eggs. Well, that's a pretty strong reason to not eat them. For comparison, toothpaste is 1,000 parts per million, and it comes with a poison warning and instructions to not swallow it. But something that's 90% of that, powdered eggs, you're supposed to swallow it. Something is seriously wrong here. So, 3 ounces of post-Farm Bill sulfuryl fluoride rice, that's a mouthful, 12% of lethal. So now your rice can do you in even faster thanks to the Farm Bill. Just for comparison, a loaf of bread using fumigated wheat flour at the optimal, apparently, level of 125 parts per million, well, that will give you half of your lethal dose. So if a child ate a loaf of bread, they have eaten half of what it takes to kill them. 5 grams of powdered eggs is the equivalent of 1 egg. Each egg, in quotes, nets you 4.5 milligrams fluoride. Since Farmer John's children always start the day with 3 eggs, they now consume 27% of their lethal dose from 3 powdered eggs. Kidney dialysis. Your life in green hands. This kidney dialysis page lists the maximum fluoride contaminant level at 0.2 milligrams per liter. Fluoridated water, mandated for 70% of Americans, has 1 milligram per liter of fluoride. Dialysis treatments take 2.5 to 4.5 hours. Patients use 400 liters of water per week, so in the range of 100 gallons a week. Kidney dialysis patients consume a lot of water, much more than the average. With 3 treatments per week, works out to 133 liters per treatment, 133 milligrams of fluoride. So, 1 kidney dialysis with fluoridated water, 266% of lethal for a 22-pound child. In other words, way too lethal. So they filter it out. Fluoride is filtered out of kidney dialysis treatment water. So why do we drink it? Kidney dialysis, your life in yellow hands. Let's perform the same analysis only for chlorinated water, using our earlier 200 parts per million chlorinated water figure. In one 133 liter treatment, 200 parts per million chlorine translates to 26 grams of chlorine. LD50 is 192 milligrams per kilogram, or 15 grams. So 1 kidney dialysis chlorinated water is 173% of lethal. Note, unfiltered chlorinated water is not used for kidney dialysis treatment. So once again, why do we drink it? Dental gel, death in your mouth. Dental gels are unregulated, boggling. 20,000 parts per million is typical and quite insane. Up to 100 milligrams in your mouth in a single treatment of fluoride. We'll first assume you swallow just 10% of this. 1 fluoride dental gel treatment for our 22-pound child, 20% of lethal. By the way, one of the flavors of dental gel, when I was doing some research, is called Bubble Fun Flavored. So that's Bubble Fun Flavored poison. Now we'll watch Billy make a life-changing mistake. That 22-pound child is going to swallow that whole fluoride dental gel dose. Works out to being 200% of lethal. Total fluoride impact. What I've done here is I've come up with low, high, and post-Farm Bill, so even higher, typical daily amounts of fluoride that people are consuming. Because after all, unlike salt or some of the other things, we get fluoride from many sources, and we have to add them all together. Bottom line, for my low estimate, you're looking at 7.5 milligrams per day, about 15% of lethal. That's the low estimate. The high estimate, having a bit of rice and taking your fluoride drops and using the stronger toothpaste and having some green tea, you're up to 50 milligrams, 49.25 milligrams. 98% of lethal for that 22-pound child. And then post-Farm Bill, the amount they can sneak into food now, and powdered eggs, and having 3 powdered eggs a day, 139% of lethal to a 22-pound child. In other words, if you follow their recommendations and take all the things that are offered to you, actually, see, if you have fluoridated water, you're not supposed to take the fluoride drops. People don't know this, but regardless, that's not even 10%. That's less than 10% of the total fluoride load. Because when you go to the dentist, they don't say, are you taking the drops or are you drinking fluoride water? They just give it to you anyway. It's really hard to stop them, frankly. So when you work it out, post-farm bill, the high limit, 139% of lethal. Even the low limit is 14 times too high for a 22-pound child. Several individual sources, mouthwash, the water itself, fumigated food, they're at the limit or higher themselves. They love poisoning us. A dental treatment is 20 times higher than recommended and 200 times higher, a fatal dose, if you swallow it. Fluoride in pet food. This document says the canine NOEL limit or level is 31 parts per million. So 100 to 1,000 times less than the NOEL rule of thumb would put the safe ingested fluoride level in dog food at 0.3 parts per million. Sadly, it appears that dog food contains 1,000 times more than this, up to 460 parts per million, thanks to the federal government allowing defluorinated phosphate, in quotes, to be sold to feed producers. Further research on my part pointed to cancers, etc., occurring at much lower levels, leading to much lower NOELs, and thus an even more criminal state of current pet food. Another page that I found cited bone meal as the main contributor to high fluoride levels, with bone cancers detected at 0.01 milligrams per kilogram of dog food. But dog foods they found were containing up to 11 milligrams per kilogram of fluoride. These numbers are the opposite of what they should be. It should be the dog food containing the smaller amount and the standard being the larger amount. That would give you that factor of 1,000 cushion. As it stands, dog food has 1,000,000 times too much fluoride in it. Tip: you can try to obtain dog food that does not contain bone meal or animal byproducts. This should greatly reduce the fluoride content of the dog food. Fluoride. In conclusion, the low daily fluoride estimate produces a risk 2.5 times greater than that from average alcohol consumption, which at 1 drink a day is twice the considered safe level. And that low daily fluoride estimate is a risk equal to that from consuming the nicotine alone in 12 cigarettes. My handbook of chemistry and physics says the safe exposure concentration, if you have to work with fluoride for 8 hours a day, is 1 part per million. So the amount of fluoride added to municipal water supplies is the limit of what is safe to be around all day, ignoring all other sources of fluoride, but at least treating it as the true toxin that it is. Does fluorosis make my legs look thinner? This would be barely tolerable if fluoride was an unavoidable water contaminant. It is patently ridiculous to do this deliberately. Lifeguards and others having to be around fluoridated water all day should sue. People forced to live with fluoridated water are at their limit from this one source, so should not contact fluoride in any other way. No one in a fluoridated area should use fluoride toothpaste, dental gel treatments, or have it deliberately added in the form of a fumigant to their food. So green tea, rice, almonds, other high fluoride foods are not an option to those being fluoridated. Treating a potent toxin as something, quote, good for you, quote, doesn't make it good for you. For more on the perils of fluoridation, watch my video, Fluoride, an Invisible Killer. It's my most popular video. Microwave radiation, lemming feed. They've done tests and it takes 10 watts per kilogram to kill a human with heat. 10 watts per kilogram times 80 kilograms yields the cook-a-body dose of 800 watts. The first law of toxicology says no human should be subjected to more than 1% of that, or 1% of 800 watts. So we arrive at 8 watts, spread over the entire body as about all we can handle. The average male adult has a surface area of 1.9 meters squared. 8 watts spread over 1.9 meters squared is 4 watts per meter squared. Converting the watts to microwatts, we get 4 million microwatts per meter squared. And in fact, that is where we are today. According to the industry-approved International Commission on Non-Ionizing Radiation, ICNIRP, an independent voice in NIR protection. But other organizations recommend less, and often much less. Levels of just 1 microwatt per meter squared are now considered ideal. So the ICNIRP acceptable dose level of microwaves is 1,000,000 times too high. 1,000,000 times too much, what gives? As the documentary movie Resonance says, we are beings of frequency. and microwaves are at human frequencies. In a way, it's like fluorine that has the same size as the water molecule, making it, number one, impossible to kidney filter the fluoride, and number two, allowing fluorine to go everywhere the water goes in the body. The word pervasive, commonly appearing in the phrase pervasive computing, is especially true for microwave radiation. Among researchers not in the pocket of wireless companies, microwave radiation, i.e. wireless or cell phones or Wi-Fi, is the most likely cause of colony collapse disorder in bees. Dr. Mercola at mercola.com agrees. And now a word from our sponsor. Sadly, all it takes to keep the harmful effects of microwaves off the nightly news is advertising. Lots of advertising. From wireless companies. Well, it's difficult to overstate the wireless radiation threat. For starters, there is vastly greater dose variation from microwaves than from fluoride, tobacco, alcohol, etc. With the latter, dose variation from one person to another is a maximum of a factor of about 100. Wi-Fi dose wars. One person could be exposed to 100 times the tobacco smoke or alcohol or fluoride of another person. With microwave radiation, the dose varies up to 1,000,000 times. That's 100 million %. If you live near a cell tower, for example, you get 1,000 times the radiation of someone living a long way away, miles away. I know this from personal experience. And as wireless speeds go up, so does the microwave radiation dose. Prying wireless from cold, dead hands. If you have wireless networking in your house, that wireless router right at your desk is putting out radiation that's 25,000 times too high. And in fact, quote, the wireless radiation from a home router is enough to damage the blood-brain barrier, quote. It seems computers are less hurtful when they are cable networked. They are certainly faster, more reliable, and more secure when cabled. Macro wave harm. Bottom line, based on the most recent published safe levels, there is no wireless router, no cordless phone, no cell phone, no cell tower, no DECT-based baby monitor, no microwave oven, and no smart anything that puts out levels humans should consider safe and comfortably live with. I've included in this video a power density graph showing the amount of energy put out by various devices and then the levels recommended, the safety levels, maximum levels recommended by various organizations. And by the way, over the years, these levels have come down, not gone up. An extensive and important subject in itself. You can learn more from my wireless radiation articles. First one's called Microwave Radiation, a Wolf in Sheep's Clothing. And the second one is called Wave 2, Microwave Hell is Coming. We've reached the final ranking top. We're in the green section, so one lead-wicked candlelight dinner on this list of toxins. That's the safest thing you can do. Lead being the safest thing on the list. That's amazing. Soda in various forms and some of the antacid compounds seem to be relatively harmless. You know, as we progress down and we get into the yellow area, we start seeing fluoride showing up. Fluoridated shower, fluoridated brushing, 1% each of those. Alcohol shows up at 2%. Fumigated rice and drinking bleach water. And then when we get into the orange section where basically I'm saying, wait, this is way above the guidelines and you should avoid this. We have 1 cigarette, makes sense. 6 cups of coffee, makes sense. That's what they tell us. Swimming, chlorinated water only, 10% of harmful. Fluoridated water, swimming in that, even worse. Eating rice, 3 ounces of rice after the farm bill. The level of fluoride is so high you should avoid rice forever. One child sneaking 1 alcoholic drink, 16% of lethal. Cup of green tea, 20% of lethal. Dental treatment, even if you spit as much out as you can, 20% of lethal to a 22-pound child. And then there's a whole bunch of red things. They're near your lethal level or are over the lethal level. Cup of green tea, 24%. 12-pack of beer, 24%, same. Cup of green tea equals a 12-pack of beer. Mind-boggling. The nicotine in a pack of cigarettes, 25%, basically the same again. So a cup of green tea equals the nicotine in a pack of cigarettes. Those eggs, 3 powdered eggs after the farm bill, 27%. Drinking an ounce of fluoride mouthwash, 44% of lethal. 1 loaf of sulfuryl fluoride fumigated wheat floured bread, 53% of lethal. A day's maximum dose of paracetamol, which is acetaminophen, 66% of lethal. Total high estimate for daily fluoride dose, 98% of lethal. 1 swallowed cigarette, 100% lethal for a 20-pound child. 22-pound child eating a tube of yummy bubblegum flavored fluoridated toothpaste, 100% of lethal. Total high estimate for daily fluoride intake post-farm bill, 139% of lethal. Kidney dialysis chlorinated water, 173% of lethal. 22-pound child swallows fluoride dental gel, 200% of lethal. Kidney dialysis fluoridated water, 266% lethal. And drinking 1.5 liters of fluoride mouthwash, 2,100% of lethal. And then in a different category, typical microwave dose is up to 1,000,000 times higher than the no observable effect level. Final thoughts. Keep in mind that the numbers reported here are conservative figures. The toxins listed here are probably worse for you than shown. Some toxins, like those in fabric softeners, are hard to quantify exposure levels for. But do you need to add chloroform, benzyl acetate, pentane, and alpha-terpineol to your freshly cleaned clothes? This document has talked mainly about toxins, but just as important is how we detoxify. Quote, the most overlooked organ that must be cleansed in order to treat the underlying symptoms of multiple chemical sensitivities and facilitate reversal of the disorders associated with the resulting maladies is the large intestine. Personally, I drink the finest water I can find, take senna nightly, and choose not to additionally poison myself with dead animals, but change is difficult. Not changing is fatal. Salt, either just in the yellow or green sections, shows our calculations are reasonable. Interesting that drinking bleach water ranks the same as too much salt. Swimming in chlorinated water makes an even worse showing, confirming my own distaste for swimming pools. It is no surprise that tobacco and alcohol are harmful, but let's give a shout out to pharmaceuticals. Even the safest drugs dip into the yellow section, with one common got a cold, take a pill holding down solid positions in both the yellow and orange sections. Gotta love Big Pharma, always keeping someone's best interests in mind. It might be a surprise to some that fluoride is so harmful. Still, 21 individual entries, 9 yellow, 6 orange, and 11 red, and 5 of those fatal, makes it hard for the trolls to blow off anti-fluoridationists with the standard crackpot label. No doubt the biggest shocker is that wireless radiation is perhaps the biggest threat of them all. Essentially unregulated, with wild dose variations and ever-increasing energy levels, microwave radiation has truly earned its Best Kept Secret award. Need to sound off or want to add a toxin? Click to send me an email. Good luck with your life. Take care.